In this lesson we're going to learn about parametric equations. So with parametric equations we can take a problem like this where we have a rock dropped from a 420-foot tower and it being modeled by the equation y equals negative 16t squared plus 420. We can superimpose this parabola onto another curve in parametric mode. So for example, we can take what we have and then suppose the rock falls in a vertical line of x equals 5. So we can include this, how the rock is being modeled, and we can also include how the rock falls. Alright, so using the calculator we can graph and analyze a table of this. So what you're going to do is you're going to take your calculator, you're going to change your mode to parameter, so you're going to scroll down right over here, it says PAR, you're going to make sure it's highlighted. Now you can go to y equals, and you'll see you have x1 and y1. So you can take your equations, so we have two equations, which we had the x equals 5, so we have x1, we can set that to be 5. And then we also had our equation from up here, which was y equals negative 16t squared plus 420. So you can put that in, we'll have negative 16, oops, it's supposed to go in y, negative 16, that t is going to be right where you usually have your x. So right up here is where you're going to find that t. It says xt theta n. And then we're going to square it plus 420. Okay? So right now I've just put it in my calculator. These are the two equations, or two parametric equations with a parameter of t. So now I want to look at how we use this. So we can take this and we can fill in the table, and that'll allow us to analyze this function. Okay, so right now I'm just going to hit second table, and it brings up this table here where I have t, x1, and y1, just like here. So I want you to take a minute and fill in this table. So the first is given to you, we have 0, 5, and 420. So take a minute to fill in the rest of this. Alright, so you should have something that looks like this. So now I want to see how I can graph it. So to graph it, I'm going to have to look at a different window than I'm used to. So I'm going to go to window, and I'm going to set my window to these following values. So my Tmin is 0, my Tmax is 5, just like in my table. T-step I'm going to make 1. My Xmin, I can see it's staying at 5, so I want to make my Xmin 0. And I can make my x max 10, so I know I'll have something on either side. X scale I'll leave at 1. Y min 0. Y max I'm going to change to 500 since we're going all the way up to 420. And I'm just going to scale this by 50. So I can hit graph, and at first you might think you have the wrong line, but in fact this is correct. If you hit trace, you'll see your t and your x over here, and it'll match your table. So t is 0, x is 5, y is 420. If I scroll to the right a little, I get to t of 1, y will be 404. T of 2, y is 356. And you keep going to t of 5, and y is 20. Okay? So now, let's look at another example. So say I want to graph x equals t squared minus 2 and y equals 3t for the given parameter intervals. So I'm going to take this and I can put it into the calculator. So I have x equals t squared minus 2. Again, that t is right here with that x button. My y is now 3t. So you can have the parameter in both the x part and the y part. So I'm going to look at a table and I want to go from -3 to 1. So I'm going to get values. So I have t, x, and y. So I have t from -3, -2, -1, 0, 1. So I'm going to have values of 7, 2, -1, -2, -1 for x. And then my y values are -9, -6, -3, 6, and 9. Okay? So now let's look at from -2 to 3. So I have t, x, and y again. This time I'm going from -2 to 3. So I have -2, -1, 0, 1, 2, and 3. So I'll show that in my window. So I have -2 is going to be, x will be 2. -1 is -1, then -2, -1, 2, and 7. And then my y values will look like -6, -3, 0, 3, 6, and 9. Okay? So let's kind of combine them and look at all of this together. So we're going to go from t of -3, -2, -1, 0, 1, 2, 3. So we actually have all of these values. So we could look, we have -3 is 7, then 2, -1, -2, -1, 2, and 7. So notice it kind of goes full circle. We have -9, -6, -3, then -2 is 6, -1 is 9, oops, -9, -6, oh here we go, 0. Then we have -9, my fault, -6, -3, -2 is 0, 3, 6, 9. So I mixed that up a little bit here. There should be a 0 and a 3. That's much better. Okay. So now we have all our table of values. We can plot these points. So let's see what this looks like. So I can plot -3. This is going to be y and x. So the t's we're not going to plot. We're going to plot our x. So we'll go to 7. 1, 2, 3, 4, 5, 6, 7. And then it'll be 9 and -9, since you have those two values here. Then we'll have an x of 2 is going to be 6, 2, 3, 4, 5, 6, and -6. Then a x value of -1 is going to be 3 and -3. Then the x value of -2 is 0. So we notice that we have is a parabola kind of on its side. So this parabola is actually x equals y squared parent function. Okay? So this is how we can include parameters and be able to graph things like this. So now I want to look at how I can algebraically eliminate a parameter. So we're going to look at the example we had just done. And our first step is to solve for t. Okay, so I'm going to take x equals t squared minus 2. And I'm going to solve for t. So I can add 2 to both sides. And I could take the square root. And then you always want to make sure to include that plus or minus. So after I do that, I can substitute it back in. I can substitute into this other equation, y equals 3t. So here I have my t, so I have y equals 3 times plus or minus the square root of x plus 2. So this is plus or minus 3 square root of x plus 2. And now I can square both sides. Okay, so then I'll have 9 times x plus 2. And here, for this, I want to solve for x. So to solve for x, I can divide by 9. And then subtract 2 from both sides. So this equation represents a parabola opening to the right, and it has a vertex of -2, 0, and an axis of symmetry of y equals 0. Okay? So that's how we can eliminate a parameter here. And now I want to look at one that's not so easy to see. So if I have the equations x equals 2 cosine t and y equals 2 sine t, it doesn't look very easy to solve for t. So look at your calculator first. Alright, so we're going to go back to our calculator and go into y equals, and we have 2 cosine t as our x, and y is 2 sine t. I'm going to change my window. T is going from 0 to 2 pi. Alright, we'll make the t step, we'll try pi over 6. My x minimum, let's try -2 to 2, and then y min -2 to 2, because that's going to be amplitude. Okay, so I'm going to graph this and see what I get. Okay, so it looks kind of like a circle with a radius of 2 and a center of 0, but it's really choppy. So one thing you need to take into account is that you're doing t-step. So if I make my t-step, it was pi over 6. So instead of pi over 6, I'm going to make it a little bit smaller and do pi over 36. And notice that makes a much smoother curve. So the more steps you take, the more accurate it's going to look. So from what we have, it looks like a circle. Our radius is 2. And our center is the origin. Okay, so let's start with that equation. So we have x squared plus y squared. So we're looking at x squared plus y squared because we want to see if it's actually a circle. So our x squared is 2 cosine of t squared plus 2 sine of t squared. Okay? This is 4 cosine of t, cosine squared of t, plus 4 sine squared of t. We can pull out a 4. We have cosine squared t plus sine squared t. And look, we have a trig identity, which is equal to 1. So we just said that we just showed that x squared plus y squared equals 4. Therefore, our prediction was true. So that's the equation of a circle with a center at the origin and a radius of 2. So that is it for this lesson. You just want to make sure you're looking at your calculator to see how to solve, give you ideas of how to solve things like this. Otherwise, you can solve for t. When you're graphing these, Make sure you're graphing the x and the y after plugging in your t values. A table is going to be helpful in helping you set the window. And you want to make sure that your mode is in parameter mode, and then you put in your two different equations in order to get what you're looking for.